In this tutorial, we will get familiar with the Project Options tool. Using this tool, we can configure any setting of the application, but for now, we will focus on the quality settings of the analysis. To get further details about the rest of the configuration tool, please have a look at the user documentation and video tutorials focused on differential expression analysis, reporting, and data loading. As we can see, the General tab consists of 5 sections. We will talk about the general settings later. So from left to right, we start with the Technical Replicate section. A technical replicate represents the same sample and detector duplicated several times to assess the accuracy of the technology. These replicates are supposed to have very similar CT values, and StatMiner is able to test whether this is the case by detecting potential outliers amongst replicates. 2 methods are available to do this: grubs and CT fraction tests. Grubs is the default method. Although both methods work in a similar way, comparing each value with the median of the replicates, CT fraction is considered more stringent for low CT values, as higher values are supposed to differ from the median. Going into details, when grubs is selected, the parameter represents the p-value of the statistical test that evaluates whether a replicate belongs to the group of replicates or not. A lower value will relax this evaluation. Please be advised that grubs assumes that your data is normally distributed. If CT fraction is the selected method, its parameter represents the distance in percentage of the value from median of the distribution. In this case, a higher distance is what relaxes the evaluation. In case automatic removal is checked, StatMiner will proceed to detect outliers and remove them before aggregating the replicates that have been left using the summarizing method indicated by the aggregation combo. In this visualization, we can see different scenarios where this detector has replicates with very similar values. This is the expected behavior. Another one, which has not been replicated at all. 3 replicates per sample, where blue represents outliers detected by CT fraction. And finally, 2 replicates by sample, where no outliers have been detected, since we need at least 3 values to determine an outlier. StatMiner notifies the account of outliers detected in the whole experiment on the right-hand side panel. Coming back to Project Options, Biological Replicate Setting describe how the application deals with the sample outlier detection and the imputation of missing values. In a similar way to Technical Replicate Detection, the application also detects outliers in the correlation of samples belonging to the same biological group. It means that StatMiner is able to automatically detect samples that are poorly correlated to corresponding samples within the group. The higher we set this parameter, the more relaxed will be the median absolute deviation test we use to find these potential outliers. Again, these samples would be removed from the analysis just in case automatic removal is checked. In this example, there seems to be a good correlation between all amygdala and cerebellum samples, but first sample within reference group seems to be poorly correlated with its group. That is why StatMiner is notifying this event. About the imputation, we have the chance to enable or disable this functionality. Imputation of missing values is performed by replacing the empty value by an aggregated value of identical detector in the same biological group. And this is the aggregation method we want StatMiner to use. Let us continue with the detectability settings. It is important to know that no action or data is modified according to these settings. The target of these quality values is just to notify those detectors with a very low level of expression and to allow us to decide whether we can trust the biological results being reported. In short, this parameter defines a CT threshold where all the CTs above it will be flagged. According to this value, one biological group will be flagged for a certain detector if the percentage of flagged biological replicates is greater than the given threshold. All of this information is reflected in the differential expression report. As we can see in the volcano plot, all detectors with amplification troubles in the calibrator group are highlighted in yellow, red for target problems, and black when flags are located in both groups. We finish this tutorial by describing the last section on normalization settings. This section is about how we want to normalize our data to correct the differences in the amount of nucleic acid in the starting material. It's common to use a combination of endogenous controls to calculate delta CT values. But in case we haven't got any reference genes or the analysis consists of a large set of detectors, it is recommended to use all the targets to normalize data. In the first case, StatMiner provides 3 different methods to test and define a subset of best controls. In the second case, we will use all target detectors. Either way, the application will create a new profile with the normalization factors to be used for the delta CT computation. As we can see, these are the candidates that create the normalization profile. In this case, they are selected by NormFinder's scoring method. This is the profile as a result of aggregating 2 controls with desired summarizing method, and these are the controls discarded by NormFinder since they were not considered stable enough. Targets will be normalized by subtracting this profile. Let us go back to project options. Endogenous controls are removed by default from the differential expression analysis, but in case we want to keep them, we can check this option and they will be normalized and included in the expression analysis. Finally, there is a way to test if our controls are good enough to normalize our data. StatMiner will compare the stability of hundreds of targets taken randomly with available controls and let us know via information panel if our controls are stable enough or whether it is better to normalize data using the global expression level option. That is all. We finish by saying that as a whole view, Project Options provides 3 predefined configurations according to the stringency we want to apply to the analysis. If we check this option, Resolution Assistant tool will pop up once Click and Go is finished and will give us further details about every information, as well as give us a warning message which is shown in the information panel as a result of our settings. Please watch our subsequent tutorials to get a deeper understanding of StatMiner.